Welcome viewers, in this video we will see the details about the Thevenin's theorem. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. The explanation about the Thevenin theorem, one of the theorem available in circuit theory. Any linear active network with output terminals A and B as shown in the diagram can be replaced with single voltage source V Thevenin voltage, that is open circuit voltage, in series with a single impedance, that is Thevenin impedance or Zi. So the Thevenin theorem is nothing but if any linear active network is available with the terminal AB is nothing but load terminals. So this complicated circuit is replaced as Thevenin equivalent circuit with Thevenin voltage connected in series with the Thevenin impedance. This is the load terminal AB. So the complicated circuit now simplified with voltage source in series with the impedance. This V Thevenin is nothing but it is a V Thevenin is the open circuit voltage, that is the load terminals are open circuited and voltage across AB is calculated, that is nothing but V Thevenin. Open circuit voltage is the V Thevenin voltage. The terminal AB are open circuited, then voltage is calculated across AB, that is V Thevenin. Z Thevenin is the driving point impedance, that is all the sources are removed in this network. Then the impedance across AB is calculated, that is nothing but Z Thevenin. Z Thevenin is the driving point impedance across AB. By removing all the sources, both current and voltage sources are removed and impedance across AB is calculated, that is Z Thevenin. So after this equivalent circuit, now the circuit becomes simplified. One voltage source is available and Z Thevenin is available. This is the load terminal, load impedance. So if you want to find the current flowing through this load terminal, I equal to V by Z. V is nothing but V Thevenin. Z is nothing but Z Thevenin plus ZL. So it is simplified. The circuit is simplified so that we can easily calculate the load current. I will see this description one by one. This V Thevenin, VTH is the Thevenin voltage. It is the voltage between the terminals A and B on open circuit condition. Hence it is called a open circuit voltage. Right? Terminal ABs are open circuited and voltage is calculated, that is Z, that is V Thevenin. Z Thevenin, ZTH is called Thevenin impedance. It is the driving point impedance at the terminal A and B when all the internal sources are killed. Killed means removed. In a case of DC, Z Thevenin is replaced by R Thevenin. Right? DC means it becomes R Thevenin. So after that what will happen? If the load impedance ZL is connected across AB, then we can find the current through it is by IL equal to V Thevenin divided by Z Thevenin plus ZL, because the circuit is simplified with V Thevenin voltage in series with the Z Thevenin. So we can easily calculate the IL value, that is nothing but I equal to V by R. V is V Thevenin, R or Z is Z Thevenin plus ZL, right? So our aim is in Thevenin's theorem, the complicated circuit is simplified with one voltage source in series with the resistance or impedance. Right, we will see the one important point. This theorem can be applied for both AC as well as DC circuit. Both is possible. In a Thevenin equivalent circuit, voltage source, if the terminal AB are short circuited, voltage source means voltage source means short circuited. The current through the AB is obtained by Ohm's law. ISC equal to V Thevenin by Z Thevenin. So that Z Thevenin equal to V Thevenin by ISC. So the another formula. Thevenin equivalent circuit, we can easily calculate the ISC value. From that we can find the V Thevenin also. Now we will see the further description. So the steps to be followed in applying Thevenin's theorem. What we discussed, we will see the description. The following steps are necessary in applying Thevenin's theorem for the given network. The first one is, let the load resistance be RL through which the current IL is required. So our aim is to find the load current IL. make the terminal AB across which RL is connected. So that terminal we marked as AB. AB is the load terminal in which the load resistance is connected. In that we are going to find the IL. RL is supposed to be connected between the terminal marked as A and B. Right? So the load terminal is AB, across RL is connected, in which we are going to find the IL. Load current, load resistance, load terminal is A and B. Second point, blindly draw the equivalent circuit between A and B terminals. It is constant voltage source V Thevenin with resistance R Thevenin. So that after this marking A and B, we can draw the equivalent circuit, in which what we have voltage source V Thevenin in series with the resistance R Thevenin or Z Thevenin. Right. So the third step is, in the given circuit, disconnect RL and redraw the diagram after removing RL. Find the voltage AB, it is called V Thevenin. We know that V Thevenin is the open circuit voltage. That is, the load terminal is open circuited. That is, terminal AB is open circuited by removing the RL. Afterwards, we can find the voltage. That voltage is nothing but V Thevenin voltage. Right? That is given. Is diagram removing RL. Then RTH. From the circuit in the above step, kill all the energy sources properly. That is, both current source and voltage sources are removed. Obtain the equivalent resistance between A and B. When look back, it is RTH. Right? So it is very important that AB is the load terminal in which load resistance RL is connected, in which we are going to find the load current IL. So the ZB Thevenin is calculated by open the terminal AB. That is, load resistance is removed and voltage is calculated. That is called V Thevenin. All the sources are removed and the resistance across AB is calculated. That is nothing but R Thevenin. Right? So after that, the circuit becomes simplified with only one voltage source and one resistance or impedance. So further we can easily calculate the load current. R Thevenin can also be calculated as, in a given circuit, replace RL by short circuit. Find the current through it. It is ISC. Right? So because it is a short circuited means it is R Thevenin equal to V Thevenin by ISC. That is another formula. So in this video we discuss about the details about the Thevenin voltage. One of Thevenin theorem. One of the theorem available in the circuit theory. So the complicated network is converted into Thevenin equivalent circuit. That is, V Thevenin in series with the Z Thevenin. V Thevenin is the open circuit voltage. That is, open circuit voltage of load terminal. Z Thevenin is the impedance, driving point impedance across the terminal AB by removing all the current and voltage sources. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.